Good morning, students. How are you all? Okay, so students, as you know very well, we are going to do unit thermodynamics. Okay, because it is continuing, we are doing. So today we will do the topic heat capacity. This is also topic of the thermodynamics. What do you mean by the heat capacity? Heat capacity, it is the amount of heat. The amount of heat required to rise the temperature of a system by 1 degree Celsius. By 1 degree Celsius. Students, heat capacity is that amount of the heat which is required to rise the temperature of a system by 1 degree Celsius. मीन्स किसी भी सिस्टम के टेम्परेचर को 1 डिग्री सेल्सियस तक इंक्रीज करने के लिए जो हीट रिक्वायर होती है, that heat is known as the heat capacity. It is clear to you or not? Okay, so student, heat capacity, it is denoted by C. It is denoted by C. Okay, we can write in this way. Heat required to rise the temperature by 1 degree Celsius. So C is equal to Q by del T. This is the mathematical expression for this. What will be the unit? What will be the unit here? Here unit will be the, what will be the unit for heat? Joule. And for temperature by degree Celsius, or we can say joule per Kelvin. Joule per Kelvin also. Clear or not? Students, heat capacity, it is extensive property. It is extensive property. So what is the heat capacity? Heat capacity is the amount of heat. Which amount of heat which is required to rise the temperature of a system? How much? By 1 degree Celsius only, or we can say by 1 unit only. Because if we are rising in 1 Kelvin, then it will be 1 Kelvin also. So we can say by 1 unit. So that heat required is known as the heat capacity. It is represented by the C. And what type of property? It is extensive property. Extensive property means it depends on the amount, on quantity and size of the particles of matter present in the system. Any doubt in this? One more term is here, that is specific heat capacity. Student, what do you mean by the specific heat capacity? If we fix mass also, if we want to rise temperature of 1 kg of substance by 1 degree Celsius, then that heat required is known as the specific heat capacity. For example, so we can say that the amount of heat required to raise the temperature of 1 kg of substance by per unit, or we can say by 1 degree Celsius. Then that heat required is known as the specific heat capacity. Means अगर हमारे पास मास भी क्या है, स्पेसिफिक मास ले रखा है हमने, एक फिक्स मास ले रखा है, वो क्या है 1 kg. तो 1 kg मास है अगर हमारे पास, उसके टेम्परेचर को अगर हमने 1 डिग्री सेल्सियस तक इंक्रीज करना है, बढ़ाना है, राइज करना है, सो उसके लिए जो हीट रिक्वायर्ड है दैट इज नोन एज द स्पेसिफिक heat capacity. It is clear to you or not? Yes. So students, how can we write this? We can write specific heat energy, not heat energy, heat capacity. Capacity is equal to, what is heat capacity? It is Q by del T. Here we are fixing the mass, means some mass is also here. So Q by m del T. You know very well, mass will remain constant. Okay. So here specific heat capacity is Q by m del T. Student, when I was discussing about the intensive property and extensive property, so I have already told you that ratio of two extensive properties is always intensive, So student, you can see here this heat is extensive property, and you know very well mass is also extensive property. Clear or not? So here extensive by extensive. So here this specific heat capacity, it will be intensive property. It is intensive property. So student, heat required for rising the temperature of 1 kg of substance by 1 degree Celsius is known as the specific heat capacity. It is clear to you or not? Yes. Next term is molar heat capacity. नाम से ही क्लियर है, means amount of heat required to rise the temperature of 1 mole of the substance, by 1 degree Celsius. You know very well students, in chemistry specifically we deals with mole. Again, so amount of heat required for rising the temperature of 1 mole of substance by 1 degree Celsius. अगर हमने एक मोल सब्सटेंस के टेम्परेचर को 1 डिग्री सेल्सियस तक बढ़ाना है, इंक्रीज करना है, राइज करना है, तो उसके लिए जो हीट रिक्वायर्ड होगी दैट इज नोन एज द मोलर हीट कैपेसिटी. Clear? Then how can we write? Molar heat capacity is equal to, heat capacity is Q by del T. Here I am dealing with mole, so mole I can represent by N. Clear? So we can write in this way. This is mathematical expression for this. Then students, What type of property? Because mole is also unit for amount of the substance. So it is also extensive property, and heat is also extensive property. So their ratio will be intensive. It is intensive property. It is intensive property. And student, these are the path function. All these three terms are clear to you or not? Yes. Then students, you know very well, because in previous class we have already discussed that QV is heat at the constant volume. Heat at the constant volume. It is equal to the del U. It is equal to the del U. And QP, heat at constant pressure. It can be represented by del H. And students, from here, C is equal to Q by del T. So I can write Q is equal to C del T. Can I write or not? I can write. Okay. Then students, from here, C is equal to Q by del T. So Q is equal to C del T. And if I talking about heat at constant volume, so I can write QV is equal to CV del T. And QB means heat at constant volume. Here, heat capacity at constant volume. It is showing that at constant pressure, CP del T. Clear or not? Yes. So here QV is equal to del U is equal to CV del T. And QP is equal to del H is equal to CP del T. Then students, now this is the heat capacity at constant pressure, and this one is the heat capacity at constant volume, and they have a relation between them. What is the relation? Cp minus Cv is equal to the R. Means difference between heat capacity at constant pressure and heat capacity at constant volume. It will be a constant, and which type of constant? Gas constant. The difference between heat capacity at constant pressure and heat capacity at constant volume will be equal to the gas constant. Here R is gas constant. Cp, heat capacity at constant pressure. Heat capacity at constant pressure. And Cv, heat capacity at constant volume. Students, how can we derive this relationship? How can we derive this relationship? We will see that. We will see derivation for this. You know very well. Del H is equal to del U plus P del V. Yesterday, we studied about the enthalpy. And this was the relay. What was the enthalpy? Enthalpy is the sum of the internal energy plus product of pressure and volume. Clear? So this one was the equation for enthalpy. Now you can put values. Consider it as 3. Del H is equal to QP and QP is CP del T. Clear or not? So I can write CP del T is equal to, here del U is equal to QV and QV is equal to CV del T plus P del V. Clear? Student, you know very well about ideal gas equation. About ideal gas equation. PV is equal to nRT. Here n is number of mole. Badal, your attention is not here, beta. N is number of mole. If n is equal to 1, because number of moles may be 1 also. Okay, then I can write it in this way. PV is equal to RT. PV is equal to RT. Okay, then students, you will write this equation here. This relation. Put value. Then CP del T is equal to CV del T plus R is a gas constant. No change will take place here, and this delta, it is showing change only. So R I will write as it is because it is a constant. So change in temperature take place. So I will write it in form of del T. Clear or not? Then student, consider it force. So from here, CP del T is equal to CV del T plus R del T. Dividing, here del T is common in all. Dividing by del T, both sides. If you will divide by del T, so here CP is equal to CV plus R. And from here CP, take CV in opposite side, minus CV is equal to R. So this one is the derivation. This is the relationship between CP and CV. CP is heat capacity at constant pressure and CV is heat capacity at constant volume. Okay. So students, here see the derivation again. You know very well QV is equal to del V and QP. QP is equal to del H. Okay. So from here QV is equal to del U and we can write C is equal to Q by del T. So from here Q is equal to C del T. If I am talking about the at constant volume QV, then I can write CV del T. And here QP is equal to del H. Then from here I can write CP del T. Clear? Then students, in equation of enthalpy, that is del H is equal to del U plus P del V. We will put these values. Del H value is CP del T and value of del U is CV del T plus P del V. You know very well about ideal gas equation. For ideal gas equation is PV is equal to nRT. And if number of mole is 1, then PV is equal to RT. Okay, student, you can take N also. Then it will be Cp minus Cv is equal to Nr. It will be equal to Cp minus Cv is equal to Nr. Clear or not? You can take, doesn't matter. It not only work on 1 mole only. Clear? So here I am taking 1 mole. Then PV is equal to RT. Then put value here. R is constant and T may change. So we will put this. Then in all, here Cp del T is equal to this. So del T is common. So divide by del T in all. And finally you will get your desired answer. Clear or not? If you put here this Cp del T is equal to Cv del T is equal to N, because N is also constant here. Again, Nr del T. Then if you will divide by del T, then you get Cp minus Cv is equal to Nr. Need not to confuse for that. Clear? Then. So student, this is all about the heat capacity. Any doubt you have? Okay, so thank you. Have a nice day.